Yes, for the toxicology. Yes, Detective Jenkins. No, the DNA results were correct. The skeleton was a female. That's correct. I have no idea what a dog in a rainbow is. Okay? Good luck on your case. Thank you. Oh, hi. Mr. T here in Forensic Toxicology Lab. So, we just got done watching the video. What we're going to do today is a qualitative test in order to find a few unknowns. First thing we're going to do is go over our material list. So, the first chemical is going to be aspirin, or another name for that is ibuprofen. Tylenol is also being used. Chemical name is acetaminophen. And good old baking soda. Chemical name sodium bicarbonate. And finally, we're going to be using Alka-Seltzer, which is going to be our effervescent. This container is just going to be used for waste. Some of our reagents or indicators, we're going to be using something called acidic ferric nitrate, hydrochloric acid, and finally something called a universal indicator. I'll explain to you what that is in a second. And then we also have a beaker of just good old water there. So what we're going to do is first we're going to prepare our samples, okay? In order to do that, if you notice naturally, if we have a pill of the ibuprofen, in order to prepare it for a sample, what we need to do is use a mortar and pestle. Simply put the pill in there and crush it up into a fine powder.
Wild.
And then what we have to do is we have to now mark up our sample tray. This sample tray, as you can see, represents each of these wells will contain our samples. We've got aspirin, AS. We've got acetaminophen for AC. SB will be our sodium bicarbonate. EA will be our effervescence or Alka-Seltzer. Then we have a U1 and U2. Those are our two unknowns, okay? These are going to be the tests we're going to perform. First, we're going to put water. Then we're going to test its pH. And again, I'll explain to you that in a second. We're then going to see if there's any reaction with hydrochloric acid. And finally, we're going to see if there's any reaction with the ferric nitrate. And then based on the results that we have, we can hopefully figure out what our unknown is. Okay, so once the samples are prepared, if you can just get a close-up of this here. Notice what I've done is I've pulverized all of the product. Terrific. And then I've got them labeled, okay, accordingly. Here are our knowns, and this naturally is going to be our unknowns. So now what we need to do is we need to load them into the sample tray. So that's going to be done naturally very carefully. Okay, I've already loaded the aspirin into the 1, 2, and 3 wells here. And then I'm going to go ahead and I'm going to load up the next one. And the way we do that is very carefully so as not to cross blend. Using a spatula, we're going to put a little bit of sample into each of the wells. Okay. Okay. So as you notice, the sample tray has been all loaded up with our samples accordingly. Now, what I need you to do is go ahead and open up the Drug Identification Lab worksheet that I've given you. You'll notice that there is a grid and or table representing the sample tray. And they are labeled accordingly. This is an editable type of document. Simply open the Word doc and type in as the lab continues with your observations. So the first observation that we need to make is the appearance of the powders. And if we notice over here and we look at it visibly through the naked eye, they all look like pretty much white powders. So what I did on the next slide, and you'll see that in a second once we stop here, is I went ahead and I magnified them for you. And you're going to see a picture, and it's going to have all of the chemicals that we're using for the first trial on the OTC or over-the-counter drugs will be all magnified for you to write down your observations under the appearance. So why don't you go ahead and take a second and go ahead and do that. Hey, welcome back. So, you went ahead and I gave you a couple of minutes to take. You should have all of the appearance filled out here. That's aspirin, etc., along with the unknowns. The next test we're going to do is the reaction with water. So, as I'm going to be utilizing this test, we have a beaker of water here with a little dropper. Okay, just a little drop of water in each one. And I want you to go ahead and just zoom in on that if you can. And then watch the reactions with each one and make observations. Observations, back up to me, please. Observations could include no reaction, which is labeled on there. You would write NR or no color change or whatever. Any kind of color change you might see. Any kind of bubbling or fizzing or nothing at all. So let's go ahead and see what happens. So go ahead. Well, first we're going to take the water. We're going to put it in the first well. Make your observations. Now what I'm going to do is I'm going to go ahead and mix each of these solutions using a little mixing stick. Okay, and what we're going to do is make sure we mix that up a little. That's fine, and we're going to be using different cups, different sticks for each cup. And all we're doing right now is simply mixing that water in for our next test, which is going to be the pH test, and I'll explain to you that in a second. Next test we're going to be using is called the pH test. And in order to do that, we use something called a universal indicator. A couple droplets of that is going to change the colors of these wells to match a particular color on the pH test chart, the indicator over there. Okay? So a couple drops of that, and let's see if we see any kind of color change in anything here. Just a drop of one, drop of two should suffice. Using the pH test chart, go ahead and give your best guess as to what each of these pH values are based on the color change that you see. Doesn't have to necessarily be exact, but do the best that you can. Next test we're going to be performing is with an acid. Hydrochloric acid is the solution that we're going to be using. It's a low concentration hydrochloric acid, but we're still going to be putting on our goggles, gloves, and a lab coat. Because anytime we do any chemicals in the lab or at home, we want to do that. So we want to see if there's any reaction with the hydrochloric acid. Okay, now it looks like our final test in this qualitative process would be using the acidified ferric nitrate. We're going to put a couple drops in each one and tell me if you see any reactions. Please write them accordingly on your sheet. Any color change we're looking for, any reactions whatsoever. You're looking for color change that match You're looking for reactions that match. All right, so that's the part one of our lab today. Finish up any of your observations on the lab worksheet. And based on the observations that you have seen, see if you can figure out what unknown 1 and unknown 2 are, and then write them on the bottom of the sheet. Obviously, type them in to the work doc that I've provided. Welcome to part 2 of the Forensic Toxicology Lab. Now, since we've done some over-the-counter drugs, and hopefully you figured out what those 2 unknowns are and completed this worksheet, now we're going to do some illegal drugs, okay? We're going to go ahead and test for illegal drugs. So why don't you come over here, and I went ahead and I've already loaded the samples with M for simulated marijuana, L for simulated LSD, and C for simulated cocaine. The samples that we're using are coming from, here they go, that's your simulated LSD, your simulated cocaine, and finally the simulated marijuana, which I'd like to give a big shout out to Chemtech for coming through with the refill supplies for me in order for me to do this experiment for you guys virtually like this during the pandemic that we're having. So what we're going to be using in order to do the tests on these, also provided by Chemtech, thank you very much, is something called Scott's reagent. Okay? We also have something called Van Erck reagent. And finally, again, good old hydrochloric acid, low concentration. These chemicals, while if ingested, are poisonous, so we are using lab goggles, coat, in order to make sure that we're safe. So why don't you kind of zoom in here, and as I put the different solutions into there, you've been given the drug identification lab worksheet. Simply fill out what the appearance is on these for the first one, the first row. The marijuana, the LSD, and the cocaine. Now, you can't really tell by appearance on the wells. Please come up to me. So again, what I did was I magnified them for you, and in the next slide, you'll see the products under different magnifications. If you just put a couple descriptions on the appearance, that'll be great. Okay, great. I hope you had a chance to write something on the appearance based off the next slide. Now we're going to go ahead and if you could zoom in on the trays themselves. I'm first going to apply hydrochloric acid to each of these wells containing the simulated drugs and make note of the reactions and or color change or anything you see. A couple drops of the hydrochloric on the marijuana, a couple drops of the hydrochloric on the acid, and finally on the cocaine. I'm going to ahead and just use another stir, see if there's anything going on there. Different stir for each one in order to avoid any kind of contamination. Okay, so please write your observations in there. Now we're going to go ahead and we're going to use SR. What do you think SR is? You got it. Scott's reagent. Let's see if there's anything going on with our Scott's reagent and any of the simulated illegal drugs. Okay. That's in the marijuana. That's your acid. And there's your cocaine. Color changes, fizzing, anything like that. Go ahead and mix that up a little, see if that makes any difference. Okay. Now finally, we're going to use something called the Van Erck's reagent. That's the VU. That's the wells going over there. Okay, so we're just going to grab a little of this. Stuff, as you can see, is a little on the reactive side already. So we gotta be a little careful with this stuff. Okay. Let's get a shot of that. And up to me. Great. Take a minute now and fill out the chart. Part 2, observations that you've seen, the reactions that it had with the different reagents and chemicals that we used, and then fill out your post labs. Thanks for watching. Have a great day.